Okay, so last class we talked about finding the clearance between a point and a line. And one of the big principles that we talked about last time was that if we had two lines that were perpendicular to each other and one of those two lines was in true length view, then those two lines appear as perpendicular lines. So that will be especially important today as we look at two lines and their relationships. So the big principle of the day, if we want to find the true clearance distance between two lines, what we're going to need to do is find the point view of one of those two lines. And then once we have that point view, then it's pretty similar to what we did last class period when you had a point and a line. So if you have a point view of one of those two lines, then you can connect it with a perpendicular line to the other line, and that's your connector, and that's the shortest view of that connector. So just to kind of take a look at a couple of lines. So if I have two lines, A, B, and C, D, and they cross over somehow with each other, if I get one of these two lines in point view, then the quickest distance, no matter which direction this line is pointing up or down, the quickest direction between this point view and that line is a line that starts at this point and goes perpendicular to this line. So again, it really doesn't matter if it's skewing up or down, it's still going to be the shortest distance between the two lines, a perpendicular. And it really doesn't matter which one I find the point view of. If I find the point view of this one, that value should be exactly the same. So that's the plan for today. We're going to find the true length of one of the two lines and then the point view, and then we'll be able to find the clearance distance between them. So not totally unlike what we did the other day. So let's take a look at this here. So here are two lines. One crosses over the other, and I want to find the clearance distance between them. So again, the first thing I need is a true length line. I don't have any parallel relationships with the hinges, so I don't have any true lengths. So I'm going to need to construct one. Now at this point, we're not really talking about slope or anything like that, so you could really come off of any of these four lines wherever you have the most space. So let's say I create a hinge parallel to CD, so that will give me CD in true length in this view here, and then AB. Then I can go perpendicular to CD to find the point view of CD. So I'll project those across. And now the shortest distance between these two is a line that starts at this point view and goes perpendicular to this line. So that is my clearance distance. So if you're asked to measure the clearance distance, that's going to be the value right there that you want to measure. Then from there, I'm just going to project back to the other views. Now, in grading the assignments last time, I think there were a few people that had issues with this part. So wherever this intersection is, I'm going to project that back across this hinge to where it hits, there's the value, to where it hits line AB. Line CD is true length, so that means I can connect it with a perpendicular. And that's the only time you can connect it with a perpendicular, is if one of them is true length. So then now I've got two intersections I need to project back. So where this intersects CD, again, make sure you don't just stop at the first line. This is on CD, so I'll have an intersection here, and then where this one hits AB, then this is going to be my connector, the shortest connector, or the perpendicular connector as we'll call it. So you'll be asked today to label two different types of connectors. One of them is the PC for perpendicular connector. So in each view, I'll want to see the PC next to this connector. So again, my last step, I've got two intersections now I can project up. And again, it's just a matter of keeping track of which way this line should go. So a lot of people draw that line backwards because they didn't project properly. So that's the biggest thing to watch out for. All right. So let's talk about vertical connector. And I'm going to switch gears over here again. Let's say that this is my top view, and I'm looking down at my top view. If the two lines cross in the horizontal plane, then it's possible for there to be a vertical connector, because remember, a vertical line shows up as a point in the horizontal plane. So where these two lines cross, that's where the vertical connector is going to be. So this intersection can be projected down or across to any other views. If I'm in the horizontal plane and the two lines do not cross, then there's no vertical connector. We can still find the perpendicular connector and the shortest distance between these two by, again, finding a true length and a point view. But if they don't cross, there's no vertical connector. So as we take a look at this particular example that we just ran through, I look at the horizontal plane, they do cross. That means a vertical connector is possible. All I've got to do is take this intersection and project it perpendicular into the next view, and here is my vertical connector. And then you'll be asked to show your connectors in all views. So these two intersections that were just created, I'll project into the next view and show my vertical connector there. So each view will have the PC perpendicular connector and the VC vertical connector, unless it's not possible. So in this case, the two lines don't cross on the horizontal plane. There is no vertical connector. So let's take a look at one or two of these in AutoCAD. So as usual, if you go to New and Templates and Additional Files, we've got the clearance practice in here. Now you might have saved this to your folder the other day as clearance practice. You might open it up from there instead. It's totally up to you, but this is where we had done the clearance between a line and a point. So now we'll take a look at this example here. So shortest distance between two lines, perpendicular connector. I need a true length line, and I really have four choices. I can go parallel to this line, parallel to that one, to that one, to that one. Since I've got the most space, I'm going to go parallel to AB here. So let's start with my hinge line. And as always, you can try and do this with me to get a good feel for it, or you could just observe. The solution is there if I thaw that layer out. So I'm going to do my raise from A and B. Go 2 views back for my offset. A is my close one. And B is the far one. Which means this is line AB and it is true length. Oops. Please continue proper labeling, so label that as TL. That'll help you out anyway, so that you know you're going the right direction. And then I'm going to copy my labels. I'm going to be lazy and not put my subscript on there because I want to keep moving. So there's AB. Now I'm going to bring across CD. So really it's the same thing we've been doing, just a little more time consuming because we've got more points to bring across and of course more opportunity to mix up the points. So you want to be careful. So D is my close one. And C is the far one. All right, and again, I'm going to copy some labels over. All right, so AB is my true length line. So in my next view, I'm going to go perpendicular to AB. So once more, I'm going to draw a hinge line here. Perpendicular to AB. And then project across. So I'll start a ray at A and go through B, perpendicular to the hinge. 2 views back for my offset. A and B are the same. That's what's going to give me a point view. And there is my point. Still see some labeling issues on some assignments, so I don't know if it's not understanding it or just maybe not paying much attention, but remember the closest point is the first one. So this one would be B2, A2, assuming that I've got my subscripts in there. It's also my point view, so I can label it as my PV. And then now I can bring C and D across. B is my close one. C is my far one. So that would give me a line like so. Now that's not true length or anything, that's just a projection of line CD. So I don't need to label it. So it should wind up with something a little like that once you've projected everything over. All right, so as we talked about our solution principle, once we see the one of the lines in point view, then we can connect those with a perpendicular line. So I'll draw a line from this point view perpendicular to the other line. Again, this one's not true length, but it's still a perpendicular connector. It's still the shortest distance between them. So labeling wise, you'll often again be asked to just label it as the PC for the perpendicular connector. And you might be asked for the length too. So what is the clearance value? So I'm going to use my aligned dimension and find that I have a clearance of 32.02 is what I came up with. Keep in mind the solutions are up here as well. So you can thaw out that layer and take a look up there as well. Didn't have the dimension on that one, but looks like it's the same. And then I just need to show this connector in all views. So I'm going to take a ray from this new intersection back perpendicular to the hinge. Where it crosses CD, I'll start. And then I'll draw perpendicular to AB because AB is in true length. So from here, perpendicular. There is my perpendicular connector. And again, I'm going to label that with a PC. No need to dimension it in this view for sure because it's foreshortened and it wouldn't tell us anything anyways. So now I've got those two intersections that I'll project back. This one intersects AB. And again, if you want to do it one at a time just to keep them straight, that wouldn't hurt. So there's the AB intersection. Because usually the points missed on this one are just from getting this backwards. This is where it hits CD. Go. And so there is my perpendicular connector in the horizontal plane. And again, I need to label that as PC. And then I'll take those 2 points down. So ray from here down. And that's where it intersects AB. And then another ray from CD down. And there is perpendicular connector in the front view. So again, the whole idea, find a true length of one of the lines, then the point view, connect it with a perpendicular line, and project back into all views and label as PC. Is a vertical connector possible on this one? I'm seeing some head shaking. Good. So we look at the horizontal plane. Do they cross each other? No, they do not. So there's not a vertical connector possible. So we look at this one over here. Is a vertical connector possible on this one? Yeah, they cross over. So it's just a simple matter of projecting that intersection into the adjacent views. And there is my vertical connector, which again I would label with a VC. Now it will get a little busy in here because you're going to have a perpendicular connector in here as well, so just do your best to label them and make it clear which label goes with which line. So I'll finish this one up real quick if you just want to observe. So I've already got a true length line. CD is parallel to the horizontal plane, so CD up here is true length. So I'm going to create my hinge perpendicular to that. And again, I'm going to buzz through this quickly, so I'm going to use all my favorite keyboard shortcuts to do this. offset of C and D. There's my point. And then now I can take A and B. 2B's back. A is the close one. B is the further one. So I have a line from here to the intersection of these two. Erase, erase, erase. All right, so there's my point view. There is my projection of line AB. I can connect those with a perpendicular line. They're perpendicular. That's going to be my PC. And again, if I'm asked for it, I'll dimension it. And then I'm going to use array to project that intersection back. Where it hits AB, I can then draw perpendicular to CD because CD was true length. So from here, perpendicular. Whoops. And then I can take those two intersections down. So CD on the left, AB on the right. CD on the left, AB on the right. And then again, label PC. And label PC. Now for the vertical connector, there's nothing to show up here in this view. It's where they cross. So you don't have to label that. It's self-explanatory. But I do need to show my vertical connector in all views. So that means that I also need to take this intersection and project it perpendicular to this hinge. And therefore my vertical connector would be from this point to this intersection. And then again, I'll label that VC. So if a vertical connector is possible, show them in all views. So what I'd like you guys to tackle today are just a couple of space drawings here. Space 3 and 4. So let's look at these. So space 3, I already have a true length, I already have a point view. So this one should be pretty easy to draw in some connectors. Is a vertical connector possible on this one? No, they don't cross in the horizontal view, so no vertical connector possible. Is a vertical connector possible on number 2? Yeah. So then you'll need to find your point views, find your perpendicular connector in all views, and your vertical connector. Now I don't ask you for dimensions on these, so I just want to see labels of PC and VC. And then space 4. So is a vertical connector possible on number 3?
Yes.
Yeah, they cross over in the horizontal plane. Number 4?
Yes.
Yeah, cross over on the horizontal plane. And if you need to on any projecting, if you need to stretch out this hinge, feel free. By the way, I told you guys not to do this, right? Not to grab the grip and stretch it. It's okay when I'm locked onto a polar angle, since it's already at a 0 angle, it's okay. It's when you're at an angle that messes up. But you can still use the lengthen if you feel better about that. All right, so any questions about what you're expected to find today? Let me know if you have any questions.